Today, we are joined by Richard Halsall, CEO of Halsall Fans. We'll be discussing modern cooling technologies and how they are reshaping building operations. This includes energy efficiency, indoor air quality, and what practical changes building owners and operators can realistically implement today. Richard brings experience from scaling a hardware based solution in the space, so we'll also touch on what works in practice versus what sounds good only on paper. Richard, thank you for joining me today.
Well, thank you very much for hosting this. It's an honor to be with you and your team.
Thank you. My pleasure. Richard, to set the stage, could you briefly walk us through your background and how you became involved in cooling technologies and building systems? Because I think this will help us understand the perspective you're bringing into the discussion, especially from a technical and business standpoint.
Well, my major background is aviation. From the age of 14, I've been flying aircraft, rotary craft, as well as heavy transport jets. So, airline background as an airline pilot and as a military pilot as well. However, I grew up in an environment with my brother and my father where we were technical in nature, and we always looked upon life from an engineering lens of solving problems. So that carried over in life, and I have been writing patents from the early 70s and inventing things and being awarded patents from my 20s, my mid 20s, on throughout my life. I've never lost interest in science, and I've never lost interest in anything to do with improving life. And that kind of brought us to this project, which was specifically to look at um, changing what has been a two-dimensional answer to a three-dimensional problem. So that kind of a little bit of my background, but also an indication of what my um, enjoyment in life is about.
Quite a journey from aviation to cooling systems. Very impressive. Now, I would like to talk why cooling is often overlooked, because this is what I've noticed in the market. When we talk about energy efficiency in buildings, heating and insulation often gets more attention than cooling itself. So, why do you think cooling has been relatively overlooked?
Hey, Carol, I couldn't agree more. It has been overlooked. And it's been approached, as I indicated earlier, it's been approached in a two-dimensional form. So what do? HVAC systems use a blower and a linear answer to distribute heating or cooling air throughout our space. We live in a three-dimensional space. Thermal stratification is normally what happens. That means that the cooler air is on the floor and the warmer air is on the ceiling. It's just the nature of living. The two-dimensional systems do not distribute the air either evenly or throughout the areas that we live in. And we spend most of our time inside anyway. So our product, our device, distributes that air from floor to ceiling and wall to wall. What do you benefit from that? Well, let's look at the summer months. The cold air is lying on the floor, so we're lifting it up and distributing it. We're also, as we know, the return air vent is usually placed high in the room. So the only thing an air conditioner can do is take the return air and reduce it 20 degrees. So we are distributing cooler air back into the system, plus complete air from the room back into the system. What does that do? That allows the set temperature, and Purdue University did the quantitative analysis of this. The set temperature can be increased, and yet the ASHRAE 55 comfort standard can be maintained. Purdue proved is that you can bump the thermostat up 4 degrees Fahrenheit, 2 degrees Celsius, and you can still maintain ASHRAE 55 in the summer and or winter months. The U.S. Department of Energy states that for every degree Fahrenheit increase that you can set your thermostat to in the summer or decrease in the winter, you save anywhere from 3 to 8% in correction, 5 to 8% in energy expense. So let's just take the medium of that. That means at least you can stay comfortable by employing our device and save about 22% in energy. So those are the targets that we've looked at in order to have an impact. Now, granted, on a small scale, you know, we're not going to have a great impact, but on a larger scale, we can have a large reduction in energy demand because 70% of what you pay for in electrical or energy costs is tied up in HVAC or tied up in just trying to maintain comfort in your home or office.
Exactly. And from what we see, demand is growing quickly, especially in warmer climates and urban environments. So this feels like you explored the right gap over here.
Yeah, the world is getting hotter. You're absolutely right about that. Um, and let's look at the other logical steps of just being comfortable in a school. If students are comfortable, then they pay attention. Then their body isn't rebelling just to listen to the professor or the teacher. Um, at home, it's the same thing. Comfort leads to a better relaxed environment. The other additional benefit is also in indoor air quality improvement. So, what are you doing by lifting the air up off the ground rather than having a fan blowing on you, drying your eyes out? You're just lifting this drier, cooler air that resides at the floor level and distributing it everywhere. Along with that, as we talk, if we cough or if we sneeze, that viral area is at the lower regions from the floor to about 2 meters is where it exists. So we have seen, again, a distinctive increase in two areas: humidity reduction at all areas of the room, which by getting air moving and reducing the humidity at the higher levels of the room, you um, also mitigate mold or mildew or dust mite uh, from growing. You dilute the viral plume, so the intensity of whatever the sneeze or the cough is reduced significantly, so it doesn't always lead to infection of another person. Uh, so the benefits that we're looking to solve don't aren't limited to energy reduction. They're also indoor air quality improvements, and so this, if you look at our product as a system, it does give a solution path to a number of items that uh, we all should be concerned with.
I totally agree. And of course, it has a direct impact on our everyday life. So thank you very much for that. And now I would like to talk about the shift toward modern cooling approaches. If you could tell us what defines modern cooling technologies today and how do they differ from traditional HVAC systems, which stands for heating, ventilation, and air conditioning. So you've just mentioned that, for example, the angle or the way the air blows, for example, in your solution. Are there any other?
Well, and they're available. There are others, of course. There's geothermal as one that uses just the nature of the planet to generate cool or generate heat to provide it. Uh, Very net zero, but very expensive to put in. Obviously, improvements in compressor technology, heat pumps have become more efficient. And for every one of those improvements in how we generate cool or how we generate heat, we still were lacking in how to distribute that heat or cool air uh, that we do generate. So that was the one glaring example to me that um, also promoted getting into complete area distribution of heat, heating, and air. But yes, there are numerous improvements in compressor technology, heat pumps, geothermal heating and cooling. What we believe is that we're the low hanging fruit, that to install our system doesn't require modifications, doesn't require replacement of existing heating and air systems, but you can just use our system as an add on and get results and, well, put money back in your pocket, because look, Karol, energy isn't getting cheaper. I wish it wasn't that way, but it is. In my 76 years, usually when things go up, they don't necessarily go down. We do excite enough people that this becomes broad based and, solves a problem for all of us in electrical generation, which is polluting our environment, to just making comfort for people as well. But it is a very cost-effective way to do it. We build the product to last. It's at minimum, life is 15 years, and that's the only reason we say that is it's a permanent magnet motor. So the magnets begin to lose their strength at about the 15-year level. Not that the product will stop, but it'll just slowly, get a slower RPM. Uh, but but I really think that whatever technology that we supplement in order to get away from high energy expense, um, we still have to look at, are are we getting what we paid for?
Mhm.
Are we getting the comfort? You know, the linear approach, if you're sitting in front of the vent that's blowing air, you're uncomfortable. And if you're laterally away from it, you're uncomfortable. Right? I mean, the guy or lady who is getting that direct air at a high speed, um, normally the body rejects that as a draft. So by by distributing the heat or the cool uniformly throughout the three-dimensional space, you also don't have to use a high speed, excuse me, to fill the room, because the only reason it is at a high speed is to get it from one side of the room to the other, to distribute it. So I truly think that from a solution path, by improving the distribution of the heating or cooling source, you do solve many problems, because you can even reduce the blower speed uh, of the air coming out, because now you have this unique distribution system.
You've just mentioned the role of cost efficiency. Now I would like to switch and also talk about energy efficiency in practice. What does it mean? Because there are many claims around energy savings in cooling. But from your experience, where do the most realistic and measurable efficiency gains actually come from?
Well, in my experience, most of it comes from being able to increase the thermostat and still maintain the comfort level that you want. In other words, don't work the system as hard as you do just to be comfortable. Um, uh, so the ability to have your body still be comfortable and um, save energy comes from moving the thermostat either up or down uh, for winter or summer, and respectively, and um, not work that system, that HVAC system, 24/7. Look at it this way: if I reduce the duty cycle of my HVAC system, especially in the summer months, if I don't work it as hard as I that what we're exposed to working it. In other words, a compressor isn't running 24/7. just to keep me cool in the summer months. Then that compressor mean time between failure will increase. Okay. So I increase the lifespan of the compressor by reducing the number of hours in the day that it is operating just to maintain an indoor environment that's comfortable. So, other areas of energy savings can be to putting in new windows, you know, uh, new doors, uh,
Or better insulation.
yeah, and better insulation on the inside. But you don't want to make the inside sick. Remember, if you seal it too much and you don't have any outside air, uh, that's not a good thing either. So the balance that we need as just being human, just because we are human, the balance that we're looking for is to get to maintain comfort without spending a fortune for it, yet maintain a healthy indoor air quality as well.
And how do modern cooling solutions impact indoor air quality and occupant comfort compared, let's say, to traditional systems? Because this is often discussed separately from energy efficiency, but in practice, at least this is what I think, both need to be addressed together.
Carol, I think you're right. They do need to be addressed together. They are not exclusive of each other. I mean, uh, like I said, most of our lives are spent indoors, uh, and because of that, we do have to be aware of the indoor air quality. So the major uh, area, the viral, what is labeled the viral plume, is from the floor to about 2 meters high as well. And that is where the density of particulate matter is maintained. So, what do we do to hopefully disperse that in a standard HVAC system? We just look at the return air to pick it up and the filter to catch it. But the return air in all systems is limited. It's high on the wall, and it only picks up air from a local area. So it's not doing the job that we would like to see it do. And I don't want to beat a dead horse, but that's why I'm going back to what we do. We're actually vertically lifting air up into the system and distributing it 360 degrees at a very high level, at the ceiling level. That's feeding the return air as well. And if you can get more into the return air system and let the filter catch it, you're helping yourself. Because again, the engineering is a wonderful thing for us. I mean, we can stay in a much better have a better sleep if we're cooler at you know what in Phoenix, in that area, even in March, they're already breaking 100 degrees. So they're using their AC portion of the system. They're using it more time during the year than they have before, just due to the climate differences that we're experiencing.
I lived in Phoenix, Arizona for almost a year, so I can confirm.
Right. Very good.
It wouldn't be possible to survive without AC for a couple of hours.
No, exactly. Um, many people live there. Look at what would be beneficial on a broad base if 22% of the current uh, electrical usage for HVAC was reduced just in the Phoenix area. I mean, that impact alone would have have a very positive effect um, locally, as well as from the generating plants that feed it. I I think that as I was trying to allude before, I truly believe, Karol, that given the tools that engineers had, the best solutions are pretty much available for linear distribution of HVAC air. But you can't fight physics. You know? Physics is the rule. Cold air's on the floor, hot air's on the ceiling. And unless you redistribute that uniformly throughout, there um, it it won't get any better. And that's what we supply is that unique solution set for distribution, which has been ignored. And that goes back to what you alluded to earlier. What hasn't been done? What has been ignored in cooling systems? And that is the most singular um, deficiency that, and regardless of my product, that doesn't matter. It If anyone was to look at it, that would be where you would find deficiency is in distribution.
I agree. And
Yes,
now
sir.
let's look from a building's owner's perspective. How should they think about cost versus payback when considering newer cooling technologies? I want to look from a building's owner's perspective because in many cases they are decision makers and they need to balance upfront investment with operating cost reductions. So clarity here would be very important.
Well, and absolutely. And look what building owners have invested in. They've invested in building management systems, these computer driven systems that turn lights off or turn lights on, or put sensors in rooms, so they're looking at reduction of wasting energy. They're uh, all these mechanical systems and technical systems to accomplish a reduction in energy usage. But now they're facing higher and higher costs. Uh, Everyone is the homeowner, the building operator, the building owner, the school board, uh, everyone in the world is looking at higher costs for electrical energy, and we're becoming more and more dependent on electrical energy. You live in Canada. A couple of cords of wood for a potbelly stove in the winter is pretty expensive, you know.
That's
And
correct.
and our customers in Canada, many of them have A-frame type homes, and I can understand why you don't want snow loading on a flatter roof. Uh, but you know, this product distributes the heat. They don't burn as much wood because that pot belly stove, it's nice and warm in close proximity, but if you walk away from it, you're not getting any warmth. Um, but let's get back to your question of, of a building owner or a school board or a university that has dormitories, et cetera, et cetera. Automation is a wonderful thing, and it'll probably assist in cost reduction. But the cost reduction is in low percentage uh, that you're getting from it. Uh, uh, we want to make that more. We want the building owner to also, you know, COVID's over, people are coming back to offices, et cetera, et cetera, et cetera. You want your people comfortable, and yet you want to save money simultaneously. So, again, the same features exist. The ability to increase the thermostat yet maintain comfort, because even though you have 72 Fahrenheit on the thermostat, the air coming out of the AC that's lying on the floor is 20-degree colder than the input air. So it's 62-degree or 58-degree cold air that's blowing out of that vent. And it goes one place. It goes to the lowest point of the room because it's denser and it's heavier. That's physics. that does, you know, that doesn't change. So mechanically, we have to lift that and distribute it everywhere efficiently. Um, again, um, go for the low hanging fruit. Go for a proven, inexpensive implementation that gives you more bang for the buck. Uh, and and that would be, um, you know, what people should be looking at for HVAC efficiencies and reduction of operating costs. Because the bottom line is just that, Karol. We want to be able to reduce our operating costs throughout the longer hot months that we have, and yet maintain maintain our comfort. So that's that is the critical factors as far as my concern can articulate to you.
And of course, that could be combined with solar energy and so on and so forth to get energy efficiency. And how feasible is it to implement modern cooling solutions in existing buildings rather than new developments?
It's you have to go for simplicity. Okay, so implementation of modern systems. Um, the more complex they are, obviously the investment is going to be greater. And when I say more complex, I mean the building management systems that change the aperture of the venting, uh, 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 the HVAC output vents, uh, uh, and then adjust um, other aspects of the heating and cooling systems to adapt. Uh, Again, for all of us, implementation should be what gives me the answering the critical question of what gives me the best opportunity uh, to save not just energy but dollars uh, and or rooms in Canada's case, uh, but save dollars for the least amount and yet have longevity associated with it so it will last. For us, we built we built that way. We doubled the size of the bearing package on the motor just to assure that it would last. So the original engineering specs, we went above and beyond just to assure it lasts. And I think if any um, logic associated with implementation of products or methodologies to provide a reduction in energy, which helps the planet, but also saves saves us cost. Um, you have to look about how much am I going to get for how much it costs, and that's it. And we are making headway in that uh, department. We're going to be installing 721 units in a new apartment complex in New York City. And we're working with the all inclusives in the West Indies um, to reduce mold, which they have a real problem, and also save energy in their facilities. So um, people are seeing that we do provide a solution at this point. Um, but that's what I would be concerned with in implementation. How complex and how expensive is it for what it returns to me? You know, we. I always like to give the afterburner concept. Um, People think that more force is the solution. I'm going to turn on the afterburner and that will solve my problem. Uh, when in actuality, finesse has its place as well. You know? And so, um, if we look at solution sets and implementing solution sets, we have to be open to things that may um, may not be in our comfort zone, as far as our thought process. Blowing air harder into a room is it may get the cold air across the room, but it's still gonna go to the floor. It's still gonna lie on the floor. So that's what I'm saying. You don't need to force things to get a better outcome. Uh,
Let's use the logic and physics.
Right.
And
Yeah.
at the end of the day, I think money talks, as we know. So as long as you are able to show those decision makers, buildings owners, that future savings will outweigh the retrofit cost, they should be on board.
Yes. Yes. Precisely, Carol. Precisely.
And what are the most common misconceptions you encounter when exactly discussing cooling technologies with clients or partners? Because it would be useful to separate marketing narratives from what actually holds up in practice, in your view.
Carol, what we've faced is the only reason we call it a ceiling fan is it hangs from the ceiling. It has nothing in common with the bladed ceiling fan. But the term ceiling fan seems to conjure in the mind, just blades rolling above your head. So all a bladed fan does is have a singular column of air that it blows on you, and it's not the most comfortable item to have. So that is an obstacle to us. But I I just didn't know what to call it back then. We're changing. We're calling it an engineered airflow system. And I think that um, eh, trying to eliminate obstacles, Carol, that are in our way, uh, to change the mindset of what what solutions we offer, um, has been an obstacle in advanced systems that are keyed for distribution, and and I'm looking to overcome that, as well as overcoming what we just previously talked about, brute force. You don't need to spend a lot of energy just delivering the cool air into the environment. You can do it with finesse.
Got it. And now I wanted to check how scaling hardware looks like in sustainability, because you've taken a hardware-based solution from concept to broader deployment. So what are some of the challenges of scaling physical products in sustainability space?
I I would say one. Let me give an example that
Real
would
life
just, yeah, a real world example. Uh, the University of Science and Technology in Hong Kong um, is populating our fans in many areas within the university, and this was spearheaded by their sustainability college. Uh, so um, they're doing it. Hong Kong's hot. Okay, it's a hot place, and they have used our fans for a couple of years, and now they're putting more in. They wanted, for the obvious reasons, to put it in their lecture hall. Okay, their their lecture hall has many things hanging from the ceiling: projectors, speakers, other lighting, vents, sprinkler system, et cetera, et cetera, et cetera. So, in in order to overcome the actual physical density of what's hanging in their ceiling, we had to get creative by not just varying locations, but varying the height of where we position the fan. So we have what we call a dowel rod that um, we fabricated in order to accommodate that. And we're still working with them to finish that particular project for their lecture hall. But in the other areas, we should be next month installing the fans. The good thing about working with the university in that is they're also going to take the opportunity to make many, many measurements for indoor air quality and use it's funny because they're putting their graduate students to publish the paper on the improved indoor air quality as caused by the fan, you know, and so that was something that we came head to head with that was an obstacle to installation. Other than that, there's remember we are um, capable of overcoming things, but of course, um, the ease of installing a fan where something might have been there previously, then that makes it easy. If not, you have to run power to it. So that's it. Our product only draws 56 watts at its maximum speed. So um, our consumption is 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 very low. Uh, so we don't have to overcome a we'll save you money, but we're drawing a lot of money to save you money type of thing. So we're not the proverbial hamster in the wheel, getting nowhere. Um, but uh, from an installation standpoint, that's difficulties that we've experienced.
It's good to see that you came up with a solution because scaling, especially with physical products, is something many founders struggle with, especially compared to software based solutions, which is pretty straightforward nowadays. And now, if you had to point to a few practical actions that building operators can take today to improve cooling efficiency, what would you prioritize? If possible, let's leave our audience with clear, actionable takeaways rather than general recommendations.
I, I obviously what I would ask everyone to look at from my standpoint is um, the logic of efficient distribution of what you're spending money on producing. And what I mean by that, Karol, is that you're spending all this money on creating cooler air or warmer air to blow into your building, and it's it's physically doing the opposite of what you would like it to do. So I would ask you to look at the fact that the physics of the situation are fighting what your desire is. All right. The hot air that you pump in the winter is stuck to the ceiling. The cold air that you pump in during the summer months is stuck to the floor. So open open yourself to looking at distribution of what you're spending money on creating as a pathway and a problem that requires a solution set. Uh, and like I said before, I do have a, uh, you know, um, uh, what a horse in the race here that uh, is our product. But no matter what, if 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 you can provide better distribution, you you can you can save money because that's going to allow you to increase the thermostat, maintain comfort in the summer months, and decrease the thermostat and maintain comfort in the winter months purely by overcoming the physical nature of generating hot air or generating cold air. Uh, so we're putting our mindset in um, how do I use the physics of the situation to my benefit rather than letting that portion of my operation control me. I'm controlling it. So that would be the overall philosophical look that I would say, Karol. That's the way I'd approach it.
Thank you very much for that insight. And before we wrap up, is there anything we didn't cover that you think is important for decision makers looking at cooling, energy use, or building performance more broadly? This is a chance to highlight anything you feel is often misunderstood in this space. We already know that air distribution is very important, for instance.
Yes. Well, the use of automation, I would say as well. I think the integration of good air distribution with subjecting it, because look, here's the reality: most large buildings are moving towards building management systems. So obvious they're easily coupled with AI, and you can easily add good um, air distribution system to it and have AI start adding quantitative quantitative points to it to come up with a solution set for it. And look at data centers. Uh, what are they draw a tremendous amount of energy just to run it. They create a tremendous amount of heat, right? They blow cold air from the ceiling and the floor, and it still winds up on the floor, okay? Because it's the nature of things. And this is what I was discussing before, this use of force. Well, if I blow it harder, it's going to do what I want it to do. And that doesn't circulate the cold air in every nook and cranny where it's needed, nor does it aid in extracting cold air extracting the air that has been surrounding all these computers in order to be cycled through again. So uh, I would um, just open my mind to distribution techniques and integration as as part of the solution set. Uh, and I think that once you combine those two things, um, you know, you actually have the capability of. You're right. When you said that, uh, money makes the world go round, dollars are definitely what it is, but also our planet. We have to really take a look at what we're doing and change the way we look at things. Nobody
Richard,
wants to. I'm sorry. Go
no, no,
ahead,
go
Ken.
ahead.
Nobody wants to make a physical change, Karol, that's going to cause us less comfort. Okay. So, um, what happens? What is the real world effect of it? In the Caribbean and all throughout Southeast Asia, they have those singular room air conditioning units that are on the wall, and they're set to 18 degrees Celsius. Now, why? Because they only blow air in a straight line, and you have to build that cold air up from the floor to the ceiling to reach the set point temperature on those units. And the whole world puts it on 18C just so they can feel like they're in the 70s. And the cold and the dense air is still on the floor. That dense air has less moisture in it as well because it's colder, it's denser. So at head level or chest level, I have 60% humidity, just because I haven't moved the air correctly in my area. We have to recognize what the real problem is, and then solve that. I don't I don't want to sweat like a pig at night in the summer or freeze. you
The same
know,
here.
nobody does. We want to be comfortable, but let's open our minds up to what it is that will make us comfortable, and yet address the critical problems of cost and obviously our planet. Look, I'm 76. I'm not I'm not doing this for money. I don't need a Lamborghini or a Ferrari or any of that. I've had it, uh, uh, you know, tough times, difficult times, but a good life. And uh, to have an impact on the planet that's going to take a decent bite out of what we do to create pollution, um, is definitely important. It's important to me. You know, it's important that uh, kids have a have a planet to grow up in, and at least the capability of seeing all the wonderful things that I have seen as being an airline pilot from the air. I mean, the beauty of, of where we are. So that that's kind of the motivating factor. And so I enjoy what I'm doing, and I just would love to see it have an impact, Carol. I really would.
I totally agree with your final statement. Richard, thank you for taking your time to share your perspective with us today.
Carol, thank you for the opportunity.
This was a practical discussion on how cooling technologies are evolving and what actually matters when it comes to energy use, cost, and building performance. For those listening, we'll include links to Richard's work and Exhale fans in the description so we can explore further. Thank you.